Okay, it is the force and laws of motion. Today we are going to discuss the second chapter. What is force? Generally in the junior classes you have perhaps studied push and pull is a force, but that is not a satisfactory definition. Alright, so it is really an external factor. Suppose the object is here, and I want to bring the object into motion. So we have to apply a force, we have to apply a cause like this. Then there will be a displacement. Or if you want to stop it, we have to apply again a force. So really force, it is an external cause, a factor which tends to change the position direction, alright, even shape, etc. of an object. So it is an external cause, or sometimes say that it is an agent. Alright, both are correct. It is the external factor which tends to change. It is not necessary that when the force is applied, the position will be changed, direction will be changed. It is not necessary. Alright. Tends to change, मतलब कोशिश करता है. Suppose a ball is there, and applying a force like this. So the ball is nowhere going. Ball कहीं जा नहीं रहा है. It is not changing its positions. So do you think that the force is not being applied? Yes, force is applied. Because it is tending to change what it is said. So the force is applied. This is not necessary that whenever the force is applied, it will change the position, it will bring the acceleration. This is not necessary. So alright. So it is an external cause which tends to change, कोशिश करता है, the position, direction, shape, etc. of an object. So this is, some people say that force is the product of mass and accelerations. No. That is the mathematical expressions. Mathematical expression. Alright. So it is, if you write F is equal to ma, that is a mathematical expression. That force is the product of mass and expression. That is not a definition. It is not necessary that whenever the force is applied, it will bring the object into motion, it will cause the acceleration. Not necessary. It is not necessary. Sometimes the acceleration is zero, but the force is working. So we will do a study in different ways. Alright. So when we go to the laws of motion, we will see here, there. We will study the force, the formula, everything is there. Now, it is an external cause. Now, when the force is applied, what happens? Effects of force. effects of force. That means when the force is applied, then what will happen? Either it will bring the object from rest to motion, or vice versa. That means if the object is at rest and I am applying a force, the object which is at rest come into the motion. Alright. This is one part of the application, the effects of force. Suppose the body is in motion. Suppose you are riding a bicycle or bike. All of a sudden something comes in on the way. Then what do you apply? You apply the brakes. The brake is what? It is a force. So when the body is in motion, you are applying the force and the body comes into rest. So that way, vice versa. Either it will bring the object from rest to motion or motion to rest. Second is this. It can change. It can change the direction of an object. It can change the direction. Suppose a bowler is throwing a ball in a straight way like this and the batsman hit the ball. What happens? The batsman is changing the direction of the ball. The ball is going like this, east to west suppose, and the batsman hits the ball and it goes to in opposite directions. So there are so many ways. What is the role of handle in the bike or wherever it is? It changes the direction like this. We apply the force. Suppose we are riding on bicycle and we turn the bicycle like this. So what? We apply the force on the handle. Though there is also called, you can say, the torque. So these things, leave it. It can change the direction of an object. Third, it can change the shape, or it can change the dimension of an object. Dimension. Better to say dimension of an object. Or if you don't consider shape or size of an object. Size of an object. Suppose there is a ball. Ball that is being played by just small children. If you compress it like this, or you apply the force like this, then what happens? Its shape little bit changes. So force is being applied here. It is changing the shape of an object. Alright. So mainly these three things happen. It is not necessarily that all the three will happen. In any one of them it may be changed. In any one of them it may happen. This may. So it is an external cause, agent, which tends to change the position, direction, shape, etc. of an object. Alright. So these are the effects of force. Now let us see the other. Before going to study balanced or unbalanced force, we need to know what is the resultant force. Resultant force. It is necessary to understand resultant force. If two or more than two forces acting simultaneously, at a point, if two or more than two forces acting simultaneously, what is the meaning? All the forces are acting at the same point, at the same body. So this is the thing, simultaneous center point. Then there is a single force. There is a single force which has the same effect as the combining effect of other individuals. Alright. That means if two or more than two forces are acting at a point, then if there is a single force which has the same combining effect, which has the same effect as the combining effect of other individuals. Let us see an example which happens in our life also. Alright, see here. You will take interest in this example. Suppose there is a body, heavy body, which cannot be pushed by a single person, and there is a buckles. Suppose two persons are applying the force like this. This and like this, one F1 and second F2, this way. It happens in our life. एक बड़ा सा बैग है, तो बड़ा सा बक्सा है, देखा कि ये ऐसे खींच रहा है, देखा। Now tell me in which direction the object will go. See here. This is the force which is acting like this. But can you guess it in which direction the object will go? It will go in a straight like this. When you go to the class 11, we complete it and we say it is the parallelogram law of vectors. So leave it here. अभी इसको छोड़ देते हैं, parallelogram law of vector वगैरह को छोड़ दो. So this is the, if you complete it like the parallelogram, so if you see it is the parallelogram here, alright, and what is this? This is the diagonal. So this diagonal has the same effect. It will go like this. So this force is like this. So this is the resultant force. Alright. So there are so many things there. So this is the resultant force. So resultant force is a single force which has the same effect as the combining effect of other integrals. There are so many examples here. Suppose the force is acting here and here. Lot of examples may be here. Like this. F1, F2, alright. And here it is. This is the resultant force. This then produces the resultant force. So this is a single. Although the forces are working here, suppose something theta. So there is a law, okay, R is equal to F1 square plus F2 square plus 2F1 F2 into cos theta. So leave it. So you know what is the resultant force? It is a single force. It's a single force which has the same effect as the combining effect of other individuals. So let us see here. So force we are doing discussions. Balanced force. What is the balanced force? Balanced force. If two or more than two forces are acting on a body, if the two or more than two forces acting on a body, and the resultant force is 0. If two or more than two forces acting on a body and the resultant force is 0, then the forces are said to be. Then the forces are said to be balanced force. It happens in the tug of war. Suppose there is a thread, there are three persons here and the three persons are here. Suppose like this, and this is a rope. Both are forces acting in opposite directions. Alright, like this. So the rope will go nowhere. So the body is at rest. So in this situation, if the two or more than two forces act and the resultant force is 0, that means the body is at rest. It is not going to change its positions. See in the case of tug of war, if the both parties, one party this left and this is right one, if they are applying the same forces, then the rope is not going anywhere, then we can say that the forces are said to be balanced. Suppose, next example you take the ball and apply the force like this. The ball is going somewhere? No. So the body is at rest. The ball is at rest. So we are saying that the forces are to be balanced force. So this is the thing. And if I want to change the definitions, so the body is at rest here. The force is being applied. The force is being applied, no doubt. But the body is not moving. Body is at rest. So we can say that what type of force? Balanced forces are acting. Let us see. Now here is unbalanced force. It is unbalanced force. If two or more than two forces are acting on a body and the resultant force is not 0, then the forces are said to be balanced. It is unbalanced force. It is unbalanced force. If two or more than two forces are acting on a body and the resultant force is not 0, then the forces are said to be unbalanced force. Suppose, once again take the example here. There are two parties, left and right. Suppose any one of them is more stronger and they pull the group in their own direction. Then there is a shift. Then we say that the unbalanced force is working. So it is true. Whenever we want to bring the object into motion, the unbalanced force is applied. And you know that it is always the resultant force. Resultant force is working. Suppose, don't think that you are applying a single force. No, it is not possible. Suppose, here it is. Alright. Here it is. I am applying a force. Here it is. Alright. But the duster does not come into motion. Why? It means some other forces are working on this duster against the applied force. What is that? Frictional force, contact force. So, there is a pair of forces working in the, at least pair of forces. Number of forces are working, but it's not possible that a single force is working there. Pair of forces. So initially when we test the object, it does not come into motion, that the frictional force is being applied. But when you apply more forces, then the frictional force gets defeated and this force is the resultant force. The resultant force comes into exist and bring the object into motion. So if the two or more than two forces are acting on a body and the resultant force is not zero, then the forces are said to be unbalanced force. Now, can you tell me what are the consequences of the balanced and unbalanced force? Balance and unbalanced force. Look here. Balanced force, balanced force does not bring the object into motion. No. Never. Then what can it happen? It may change. It may change. May. That means may not. It may change the shape of an object. So there is a ball and if we apply the force, two forces are working. Look here, this force is in direction and this force is in the direction. So two forces are acting having the same magnitude. If there is the same magnitude, just suppose sometimes we apply the force and does not come into motion. Try this. You know, I am pushing the wall like this. Okay, here it is. But the wall does not move in an inch. Can you tell me what does it happen? The net force, it is the net force, it is the resultant force that makes a matter. Suppose there is a iron. If you take the rubber ball, it's okay. We apply the force, we change the shape. Now I give you an iron. Then what happens? Can you change the shape? Your hand cannot apply so much force. So the body does not come into motion. So what happens really? Really that there is net force is zero. So if the net force is zero, the body does not come into motion. So if the net force is zero, then the body does not. This is very important. Net force, what is the role of net force? Does not come into motion. Look here, unbalanced force. Unbalanced force is responsible to bring the object into motion. That means if any body, that means if you want, if any body is made into motion, then we apply what? Unbalanced force. Unbalanced force. So, balanced force does not bring up the object into motion. What can it happen? It can change the shape. It can change the direction. It can change the shape of an object. An unbalanced force. Unbalanced force, what is the net force? Net force is not zero. In this situation, net force may be zero. But here the net force is not zero. If the net force is not zero, then the object will come into motion. So, always keep it to mind. It is the net force that works. You apply the simple force and you think that something is going to change. No. It is the resultant force, it is the net force that makes a matter.